Hello, I am Dr. Anubha Gupta from ABES Engineering College, Ghaziabad. I am presenting video lecture series on electromagnetic theory. This is my lecture 8. And in a previous lecture, I already discussed about the Stokes theorem, Gauss theorem, displacement current, Poynting theorem, and different properties of electromagnetic wave. And in electromagnetic theory, there are some numerical problems which I am going to cover in this lecture. First, I will discuss numerical problems on conduction current and displacement current, Poynting vector, and skin depth. So I will start with the problem conduction current and displacement current. Numerical based on displacement current. Determine the conduction current and displacement current densities in a material having conductivity 10 to the power 3 moles per meter and relative permittivity epsilon r 2.45. The electric field in this material is given by 4 into 10 to the power 6 sine 9 into 10 to the power 90 volt per meter. So as we are going to give the solution, first of all, I will write the formulas. We know that the JC is equal to sigma E. This is the conduction current density. And JD is equal to epsilon naught, epsilon R, del E by del T. So first of all, how we will calculate JC? Sigma E, where this sigma is the conductivity. So conductivity is 10 to the power 3. 10 to the power 3. And this is the electric field. 4 into 10 to the power 6 sine 9 into 10 to the power 9 into T. So JC will be 4 into 10 to the power 9 sine of 9 into 10 to the power 9 into T. Ampere per meter square. This is the solution for JC. Now I am going to solve JD. As I already write the formula, JD is equal to epsilon naught, epsilon R, del E by del T. So JD will be epsilon naught is the constant, which is the 8.85 into 10 to the power minus 12. Epsilon R, relative permittivity, is 2.45. Del by del T. We will differentiate this electric field with respect to time. 4 into 10 to the power 6 sine 9 into 10 to the power 9 into T. So JD is equal to 8.85 into 10 to the power minus 12 into 2.45. And for differentiate, this is the constant. It is outside the bracket. 4 into 10 to the power 6 del over del T of the sine. It will be cos 9 into 10 this the power 9 into T. Now we will differentiate the function of T. It will be 9 into 10 this the power 9. So this JD after calculation, this JD will be 8.85 into this. I will calculate it. It will be 780.57 into 10 to the power 3 cos 9 into 10 to the power 9 into T. Ampere per meter square. This is the answer for JD. In this way, we have solved this question. Now, question number 2. Based on Poynting vector, Earth receives 2 calories per centimeter square per minute energy from Sun on its surface. Determine the amplitude of electric and magnetic field vector. So this is the 2 calorie per centimeter per minute, means this is the Poynting vector. And we know that the unit of Poynting vector is watt per meter square. It means we will change this calorie into the joule and this minute into the second, and the joule per second is watt. So what is the solution of equation 2? We know that this is the Poynting vector. How we will identify? This is the 2 calorie per centimeter square per minute. So this is Poynting vector S, but we will convert into the standard form of watt per meter square. 2 calorie means it is a 2 into 4.2 joule per centimeter square. Centimeter square convert into the meter square. It will be the 10 is the power 4. And minute is converted into the this second. It will be 60. And centimeter square into meter square, so it is a 10 is the power minus 4. So this it will be 2 into 4.2 into 10 is the power 4 upon 60. After solving, it will be 1400 watt per meter square. And this is S, means Poynting vector S is 1400 meter square. But we know that the S is the cross product of E and H, and E and H are perpendicular to each other. It means magnitude of Poynting vector S is equal to magnitude of E into magnitude of H. So S is equal to 1400 is equal to E into H. And the ratio of the electric field vector and magnetic field vector is always 377. Around 377. So this is equation 1 and this is equation number 2. Multiply both equations. Multiply both equations 1 and 2. We will get 1400 into 377 is equal to E square. It gives E square. It gives E is equal to square root of 1400 into 377, because we want to determine the amplitude of electric field. So electric field become, it is 140 into this, it is a 726.22 volt per meter. And if I put the value of E in equation number 1, then the H becomes 1.92 ampere per meter. And these are the RMS value. So the amplitude will be root 2 into E. And it become root 2 times of 726.22. And it will be volt per meter. And H naught will be root 2 into H, which is equal to root 2 multiplied by H. RMS value is 1.92. So H naught is 2.72 ampere per meter. This is the answer of the amplitude of electric field, and this is the amplitude of magnetic. So in this question, we first convert the Poynting vector into the standard form. Another question. Calculate the amplitude of electric and magnetic field E naught and H naught at a distance of 5 meter from an oscillator which radiate energy isotropically at 1000 watt. Means in this question, we will apply the formula of the Poynting vector. Poynting vector is not given, but we will first calculate the Poynting vector. And we know that the Poynting vector is the power upon area. So if this is the oscillator, it radiates the energy till 5 meter. Till 5 meter. So power is the power, and the area in the 3 dimension will be 4 pi r square, because energy radiated into the 3D and the area of the 3D sphere is 4 pi r square. So power is 1000 watt upon 4 pi r square. The radius, we will calculate we will assume that the 5 meter is the radius. So this is the S. This is the value. This is called the Pointing vector S. And the value of S is 3.18 watt per meter square. And as we know that Pointing vector S is the cross product of E and H, and the magnitude of vector S is equal to magnitude of H E and the magnitude of H into sine 90. So S can be written as E into H. So S will be 3.18, and this is the product of E into H. And we know that the ratio of the E and H is the fixed quantity, which is the 377 ohm. So by multiplying these equation, if this is the equation number 1, this is the equation number 2, multiply equation 1 and 2. It will be 3.18 into 377 is equal to EH multiplied by E by H, which gives E square, and E will be 3.18 into 377 square root. It gives E is equal to 34.61 volt per meter. And by putting the value of E in equation number 1, H is 3.18 divided by 34.61. It is a 0.091 ampere per meter. But in question, E naught and H naught asked. So we will calculate E naught as root 2 of E and H naught is root 2 of H, because these are the RMS value. So E naught will be 34.61 into root 2. It is a 48.94 volt per meter, and H naught root 2 by 0.91, and it is a 0.128. 0.128 ampere per meter. This is the value of H naught. This is the question number 3. Now we will move further for the question number 4. This question is based on the skin depth. Find the skin depth at frequency of 1.6 megahertz in a aluminium. Aluminium is a good conductor where conductivity is 38.2 into 10 to the power 6, and permeability, relative permeability mu r is equal to 1. Also find out the propagation constant and wave velocity. This is the question based on skin depth. As we can see that here the material is given aluminium and the conductivity is 10 to the power 6, means we will apply the formula for the good conductor. Formula of skin depth for good conductor is, this is the skin depth. This is the skin depth formula for the good conductor. Delta is equal to 2 upon mu sigma omega, where we can write 2 upon mu. What is the mu? Mu is the mu naught mu r. Mu is the mu naught mu r sigma, and omega can be written as 2 pi f. In this way, this 2 is cancelled out by this. And now we will put all the values as we already know these values. As we know that the mu naught is 4 pi into 10 to the power minus 7. This mu naught constant should be learned to the student, that mu naught is 4 pi into 10 to the power minus 7. It will not be given in the question. You should remember it. Mu r is 1. And sigma is the conductivity, which is 38.2 into 10 this is the power 6. And the frequency is 1.6 into 10 this is the power 6. This is the frequency. And we will find the skin depth from here. 1 by this. It is a 6.44 into 10 this is the power minus 5 meter. This is the value of skin depth for good conductor. So first part done. Now the second part, also find the propagation constant. And we know that the propagation constant beta is equal to 1 by skin depth. And it is also equal to alpha. And for good conductor, alpha attenuation constant and beta propagation constant both are equal. So it will be 1 upon 6.44 into 10 this is the power minus 5 meter. So we will solve it. It gives 1.55 into 10 this is the power 4 meter inverse. This is the propagation constant beta. Now we will calculate the wave velocity. Wave velocity or the phase velocity can be given as velocity v is equal to omega by beta or omega by alpha. So omega is 2 pi f and 1 by beta. Here this is can be written as 1 by beta. And this 1 by beta is skin depth delta. Or we can divide it by beta, whatever we can do. 2 pi 3.14 into frequency is 1.6 megahertz, 10 this is the power 6, into skin depth is 6.44 into 10 this is the power minus 5. Now V will be skin depth. So velocity will be 6.47 into 10 this is the power 2 meter per second. This is the velocity of an electromagnetic wave for which is traveling in a aluminium. So these are the all 4 types of questions of EM wave. These are the introduction of my lecture. Introduction to electrodynamics by these are the references of my lecture. Introduction to electrodynamics by David J. Griffith. Solid state physics by S. O. Pillai. Engineering physics by S. K. Gupta.